Hey guys, welcome. I hope Christ is blessing your day and watching over you as He does me all the time. And in this video, I'm going to go through the first 12 problems on the Calculus AB 2008 multiple choice. Now, the 2012 multiple choice for the AB and BC are available, and they're the more recent available multiple choice set of questions, right? And as far as I know, only the 2008 and 2012 are available, and that is due, and I know the reason. That is due to the fact that the College Board recycles multiple choice questions from year to year, and so only the 2012 and the 2008 multiple choice set of questions are available right now. I already made solutions for the 2012 years ago, and those are some of my earliest videos. They're available on YouTube, so check them out. And as they are some of my first videos, like some of the delivery in places a little labored, but they're free, right? So there that is. And there might be a little bit of background noise because I live in New York City, nearby a busy street, blah, blah, blah. And other than that, what else did I need to say? Oh, yeah. Yeah, so in this video, I'm only going to present like the first 12. Like full solutions can be found on my Patreon page, so you can unlock them there, yeah? Okay. Need I say more before I start? No, I think that's everything. So let's get started. So problem one is a limit at infinity question on a rational function, right? Now, the way that this rational function is written, plugging in infinity is not really going to reveal much, right? So what we want to do is like unfactor it, unfoil it, so to speak, right? So let's get at it. So we'd be like limit how come I cannot write? Hold on. What happened? What happened? Let's reload this page. Okay. So we'd be like lim, as x goes to infinity. And then, like as I said, what we want to do is FOIL. So, right? Y'all know how to FOIL. So like I'm just going to get to writing, right? Okay. So that's going to be like 6x, right? And then minus 2x squared. I got to pay attention. Minus 3 so that we get this right. And then plus x, right? Okay, there's a bit of simplifying that we have to do, obviously. And then this is divided by, and then it's going to be x squared plus 3x, and then minus x, right? And then minus 3, right? And this equals lim as x goes to infinity, right? Like we have like, you know, some cleaning up to do upstairs, right? And sorry, so that's minus 2x squared. Okay, that was an inside joke, like a real inside joke. Like not 6x, my bad. 7x, right? Because we've got a 6x right there and a plus x, so that makes 7x. Okay, and then minus 3, right? Okay, and then this is divided by, and it is x squared and then plus 2x, x squared. Maybe I want to make room. Hold on, you'll see why. There's method to the madness. Okay, so x squared and then plus 2x minus 3, right? Okay, there's a guy like who plays the saxophone like habitually, and he plays like the same tune every time. It's kind of like cool. Okay, now once you get to a form like this on a rational function, you're evaluating the limit at infinity specifically. What you ought to do is like look at the highest powered x both in the numerator and denominator. We can clearly see that that's x squared either in the numerator and denominator, and you want to divide every term by that highest powered x, right? So we go, all right, and you'll see why this is revealing in a second. Oh yeah, the last note I was gonna say at the start is like, you know, I have a Yeti Blue microphone, so I could have plugged that in, but it's a little cumbersome. Like, and it's got its own set of issues. So I'm using the internal mic on my computer, and hopefully, you know, no one complains about that. Okay, so this is minus 2 plus, and then it's 7 over x, right? 7 over x right here, right? My handwriting is not as crisp as I normally like it, but whatever. We'll live. Let's just get to doing the problems, right? So, and then 1, and then plus 2 over x, right? and then minus 3 over x squared, right? Okay, and then now we plug in infinity, so to speak. Infinity is not a number, we can't really plug it in, but we can imagine what would happen to, say, 7 over x as x gets arbitrarily large. And that's clearly going to 0, right? So it's this term, and now you should be able to see why, like, this is revealing. So this is also going to 0, this is going to 0, and this is also going to 0. So we see that the whole thing is going to negative 2 over 1, which is negative 2, right? And so the correct answer, I'll circle all the answers in red. I'll try to be consistent. The correct answer is right there. Okay, moving on. All right, this is a very simple, like, integration problem, right? And so, you know, like, yeah, you shouldn't be tripped up by this. And so we'd be like integral. And so if we write the x squared in the numerator, it'd be like x to the negative 2, right? dx. And then using the power rule for derivatives, we add 1 to the numerator and divide by that new numerator, right? Sorry, not numerator, exponent. So we add 1 to the exponent, my bad, for the power rule, right? Like, so I was talking about numerators earlier, and so I'm still stuck on them. Okay, so like that, right? And so that'd be like x to the negative 1 over negative 1. And of course, I forgot the all important plus c. On this channel, you can find a video on why that plus c is so crucial, right? Okay, anyway, but it is crucial. So plus c, right? And so then we go like, okay, so this is negative 1 over x plus c, and that's all she wrote. Like they got ln involved there, just like, you know, like, yeah. Okay, negative 1 over x plus c is, ooh. Well, I think like it's just like it didn't come out, but, you know, the best answer from the choices is D. So that's what we're going with, and I did say I was going to circle the answers in red. So there ought to be like a negative 1 right there. I think it's like a typo or whatever. Okay, so that's D right there, yeah? But in any case, the correct answer is this, and I am sure of that. Let me double check, as sure as can be. Yep. Okay. So on to the next one, right? And this is a simple exercise in like the product rule for derivatives, right? Because you have a product between x minus 1 and x squared plus 2 all cubed, right? And so, you know, we have f is equal to, say, like u times v, where I'm saying u is x minus 1, blah, blah, blah. And so we know that f prime, u and v being functions of x. And this is v, right? I'm claiming x squared plus 2 all cubed is v. So f prime should be u prime v plus uv prime, right? That's the product rule. I shouldn't even have to spell it out. So now we go f prime of x, or if I just say f prime, we should know we're talking about f. That's going to be u prime, so the derivative of x minus 1, you should know, is just 1. And then times v, so that's x squared plus 2 cubed. Okay. And then I missed sketchbook. No, this is fine. Plus, okay. I'm using this because, you know, see, I can flip through the pages quicker, right? Okay, and then u is x minus 1, right? And then v is 3 times x squared plus 2 squared times 2x, right? Okay, and so if we clean up, that's going to be like, we can see that there's an x squared plus 2 squared that both that and this term could afford. And as I, you know, it's useful to quickly glance at the answer choices frequently, right? Because you don't want to do more than you need, right? And so if we look at them, they're all in factored form. So we could see that, like, out of this and this, right, we could take out an x, hold on, I gotta look, x squared plus 2 squared. So x squared plus 2 squared, right? And so, and instead of this, right, we have just a 1 since we've taken out, right? Okay, and then, no, what am I saying? So, like, it's cubed. So since that's a square, we have 1 x squared plus 2 left. So we have x squared plus 2 from this first circled item. And then in the rest of it, here we've taken all that out, right? And so I'm going to lead with that 3 right there. And I'm going to combine it with that 2 and get a 6, right? So we're going to be like plus 6, and then it's going to be times x minus 1 times x, right? And this trailing x being that x right there, right? Okay, cool. And so we'd be like, all right, so this is x squared plus 2 squared. And there's some cleaning up to do here. we've got an x squared there, and then we've got 6x squared there. So that makes 7x squared, right? So that's 7x squared. Okay. And then we have a minus 6x, because we have that minus 6 right there, and we've got an x, right? So we've got minus 6x, right? Okay, minus 6x, and then a plus 2 at the end. So plus 2, right? Okay, so one of the answer choices should read that, and it does. And that answer choice clearly is D, right? Okay, cool. All right, let's keep going. So next is 4. And in 4, we have to do the antiderivative of like this and this, right? We can, using the linearity of the integral or the antiderivative, we know that we could do each individually and in general, right? Like we know the antiderivative of cosine ax, right? You could do a mini substitution where you let u equal 2x, but that's overkill. You should know that the antiderivative of cosine ax is just going to be sine ax divided by a, right? And like kind of a similar thing to the sine 2x, it should be negative cosine 2x divided by 2. So the correct answer, I'm just going to do this one real quick, is going to be negative cosine 2x divided by 2, right? And then it's going to be plus sine 2x divided by 2, and then plus c, and one of the answer choices should read that. And which one reads that? A, right? 1/2, B, right? And obviously dividing by 2 is same as multiplying by 1/2, so let me double check. Yeah, that's the correct answer. Okay, cool. Making sure that my eyes ain't deceiving me. Okay. All right, so next is this, right? And like we can plug in 0. Notice that 0 annihilates every term because all of the terms in the numerator and denominator have x's in them. So it's very tempting to say that the answer is 0 over 0 and pick E, but you ought to think a little, better than that. It should never be that easy, right? Okay. Oh, yeah, I have my undo buttons up there also. Okay. So what you should do is like try to find the GCF in the numerator and denominator, and hope for the best, right? So we do that. So lim is x on a similar question, that is. So we go like that, and then we take out an x squared, and so we have 5x squared plus 8 in the numerator, and then we divide this by, take out an x squared there, and so we get 3x squared minus 16, right? Okay, and it's obvious now that we could be like boom, right? And so the question or the task reduces to lim as x goes to 0. The writing is normally better than this. I'm a little annoyed by it, but it's okay. Plus 8, and then all over 3x squared minus 16. And now we can plug in 0 because it's now going to annihilate everything, right? This is going to be 0 when we plug in 0. This is going to be 0. So we get 8 over negative 16, which is negative 1/2. Correct answer choice, A, right? Okay, cool. Let's keep it moving. Okay, so here we are. So it says, let f be a differentiable function defined above. Which of the following statements about f are true? F has a limit f has a limit at x equals 2. Well, let's see. So the limit, I was supposed to write in black. It's really not a big deal, but I'm going to be annoying and do it anyway. So, okay, so it would be like limit as x goes to 2, right? That's what we mean by x has a limit at 2 of well, let's factor so that, we don't labor this too much. X minus 2 times x plus 2, difference of squares in the numerator, you should know that, over x minus 2, right? And so we cancel, and we see that we have lim as x goes to 2, right? Of x plus 2, and we plug in 2, we get 4, and yeah, that's a limit. Yes, having a piecewise function defined where an isolated point is defined elsewhere means that we have a removable discontinuity. But a removable discontinuity does not preclude a limit, right? So here is a visual of a removable discontinuity. You could still have a limit. All you care about is the limit from the left and the limit from the right. Are they the same? And technically, this here is just a line. It's a line with a hole at x equals 2. And so you could quickly visualize that and be yeah, without checking one-sided limits, I know that the limit does exist. So this is bingo. F is continuous, clearly not continuous. Well, okay, maybe I spoke too fast. Yes, but clearly not continuous, because for continuity, what we need is we need the limit as x goes to a of f of x to equal f of a, right? We need this to equal f of a, right? Now, so we need the limit to equal the function's value at that x. That x we're speaking of is 2 in this case, right? So a is 2. And clearly we just evaluated the limit, we found it was 4. But f of 2 is 1 right there. And so the limit and the function's value at 2 do not agree. And therefore, it means that this is not correct. And f is differentiable at x equals 2? No way. Like, it's a removable discontinuity. So at that point, like, you're not differentiable, right? Okay. So we see that the correct answer is 1 only, whichever says 1 only, and that is A. Got it. Okay, so let's keep it moving. So here, it says a particle moves along, well, you know how to read. So that's the velocity function for t great. Okay, and if the particle is at position x equals 2, so this means x equals 2 at t equals 0. Sorry, I'm like in a rush to like, okay. But yeah, like this here, right, can be summarized as saying the position function is such that x of 0, the position at 0, is equal to 2, right? We can summarize that. And we should understand why this is given, because, well, they're asking us for the position of the particle at t equals 1. We know that the derivative of position, right, is velocity, right? And so we know that the, oh, sorry, x of x doesn't make sense. So the derivative of position is a function of time, is velocity, right? So we know that in order to find the position anywhere, we need to retrieve the position function x of t. That means that we need to do the integral of the velocity function. But then when we do, we know that we're going to get x of t plus a constant, right? And so in order to completely determine, it's x of t. I shouldn't even call it x of t, because x of t is including the constant. But in any case, we need additional information to determine what that constant is the point, right? And that's exactly why we're given this initial value, right? Okay. Because otherwise, the task is pretty easy. As I said, we need to integrate velocity, which is find the antiderivative to get to the position function, right? Okay, so this is going to tell us, this is simple integration. So that's going to be like t cubed plus 6t squared over 2, so that's 3t squared, and then plus c, right? And so this is x of t, right? But then we need to figure out what c is in order for us to say what x of t is at t equals 1, right? But to figure out what c is, it's pretty straightforward. We plug in 0 and then set it equal to 2, right? So when we plug in 0, we get 0 plus c is equal to 2. So we see that c is 2, right? And so we go, all right, now we have this. So then now all we got to do is plug in 1, right? And so I'll do that in blue. So when we plug in 1, then we go, what is going on? Okay, hold on. Sorry, guys. I'll just reload once again. Okay, so whatever. Like, yeah. Okay, so sorry, guys. You'll live. So we plug in 1 right there, 1 right there, and 1 right there. So that's gonna tell us 1 cubed is 1 plus 3, right? Jesus Christ. And then plus 2 is going to be 6. So the correct answer choice is B, right? Okay, so let's keep it moving. There's a 9 next to it. Okay, all right. So here, a simple derivative question. The only thing is that, like, you know, your ability to, like, you know, evaluate trig functions will be, important also. So first, f prime of x is pretty straightforward, right? Cosine derivative is negative sine. So we go negative sine of 3x and then times 3, right? So that's negative 3 sine of 3x, right? And so in here, we need to plug in pi over 9, because what we're tasked with, I hit the, what we're tasked with is evaluating f prime at pi over 9, right? So we go f prime of pi over 9, that is negative 3 sine of 3 times pi over 9, right? 3 times pi over 9, right? And so that is negative 3 sine of pi over 3, right? And I don't know how y'all do, like, your trig evaluation for like pi over 3, pi over 4 and that kind of stuff, but I use the special triangles, and that's very straightforward to me anyway. So pi over 3 is 180 divided by 3, so that's 60 degrees, right? So this is pi over 3, right? And we know in the 30, 60, 90, when opposite the 30 is 1, this is root 3, and this is 2, right? And so it's root 3 over 2, because we need sine, right? Opposite over hypotenuse. So then we're going to be like negative 3 times, and then it's going to be root 3 over 2. And so whichever says negative 3 root 3 over 2. And that, I think, is the last answer choice. Yep. Okay, E. Got it. Okay. 9. It says the graph of the piecewise linear function f is shown in the figure above of g. G is defined as an area function of f. So this is f, pay attention. And then g is the area of f from negative 2 on, right? So unfortunately, we have to go through each of the answer choices in a question like this. So like, for example, g of negative 3 is going to be, it's going to be the integral from negative 2 to negative 3, right, of f of t dt, right? Now, so that means that, like, since this is negative 2, we need the area here, right? But, like, look at how this is. It's from negative 2 to negative 3. No way. We need it the other way around, right? We need this guy here to be negative 3 and that to be negative 2, right? So we could do that. Okay, negative 3 and negative 2, because negative 2 is greater. But then to swap the limits, we need to throw a negative sign right there. So although the area here is positive, we see that the negative sign right there is going to give us a negative value overall, because the integral here is going to be positive because it's that little strip right there, that area. But for swapping the limits of integration, we had to throw a negative sign in front of the integral, so we know that this is negative. So it best not win. Well, I've before making the video, look through each question very quickly, a cursory look at the whole thing. So, I know that that's not gonna win. But anyway, we know that a negative value can't be the greatest, right? Okay. So G already, it's beat by B, because B would be like from negative 2 to G of negative 2 would be like the integral from negative 2 to negative 2, right? And we know, doesn't matter what function it is, let alone f of t, right? We know that like from the same value to the same value, it's going to give us an integral that's equal to 0. So we see that this is 0, so trumping A already, right? Okay. And then G of 0 is going to be like the area from negative 2 to like 0, right, under the curve. So it's that area. Okay, definitely winning right now. So we can cross out B, right? So this is winning right now. But then G of 1 is what I've highlighted in red plus this little bit more, right? And so we see that like now we can cross out C, and this is winning. And G of 2, well, it would be like the red area here, the blue area here, plus this little bit. But this little bit right here is below the x-axis, right? So it's negative area. So it'd be like taking like D and then adding negative area in it. So we see that the winner is D. Got it. Okay. Next is 10. So yeah, okay. Which has the least value. Okay, the integral from 1 to 3 of f, again, pay attention to these signs. F, the integral from 1 to 3 of f is going to be like, well, it's going to be the exact area, right, under the curve. Okay, we see. Keep that in your head, right? Like, nothing else to do. Left Riemann approximation with 4 subintervals. I don't like that they made them 4 because it like makes it like more cumbersome. It doesn't make the question harder. But in any case, they should have just made it 3 because it's like from one. Anyway. Like we use 4 rectangles, but it's saying left Riemann. Notice that since the function is decreasing, a left Riemann, say for the first rectangle, would over approximate it. So we see that like which of the following is the least. So B is like bigger than A, so we can cross it out. Right Riemann. Right Riemann so far, right? Like right here, right there, right? Okay, so yeah, like now we can cross this out because right Riemann is definitely going to be smaller. Midpoint, no, because like look, for example, on this one, midpoint is going to be using that height right there, and so it will, the midpoint will like under approximate a bit and over approximate a bit. but it'll do better than a right Riemann on a as far as like overall value, you know, as opposed to like yeah on a decreasing function, it'll do better than right Riemann. So we see the right Riemann is so far the least. And trapezoidal would be like, you know, if we drew a trapezoid, if we made a trapezoid of this, like so, like yeah, right there, right? Like it's hard to say which would give us a more precise approximation of the area under the curve, the trapezoid or the midpoint, but it's clear that the trapezoid would definitely do better than a right Riemann. Again, the right Riemann would tell us that the area, like for this rectangle, for example, is right there. You see the trapezoid would add that a little bit, and so yeah, so no, yeah, we see the correct answer is C, right? C. Um, okay, and it says the graph of the function f, again, pay attention, is shown. Okay, which of the following? So we're talking about f prime. So which of these represents f prime? Important thing to know is f prime would have to be 0 here and here. So whichever is the correct answer, it needs to have a 0 right there. It needs to go through there and there, right? Okay, so we see that that's not A. B, like, you know, fulfills that. These are rough sketches anyway. C, clearly not. D fulfills that, right? And then E, no. So now it's between B and D, right? So we got to do a little bit more. Well, the derivative needs to be positive because the slope of the function f is like increasing, right? Like from the left end of what we can see up to this point where it's 0. So it needs to be positive, which is to say above the x-axis on f prime, right? And so from our choices, like we see that above the x-axis, B, the correct answer. Okay, and then 12 is, it says like, stuff. Okay, so yeah, this is f and we need f prime. All right, so the derivative of e to anything, right? E to anything is, the derivative of e to anything, right, is equal to e to anything itself, right? E to anything times the derivative of anything, right? So times, so d dx anything, right? Okay. Well, all right, got it. So we see that first thing we gotta do is do e to anything, right? And anything being like 2 over x right there, right? Okay, so e to the 2 over x. And you should know kind of like, you know, as like almost memory, a over x, the derivative of that. So we're getting to the part where we do the derivative of anything, where again, anything is 2 over x. You should know that the derivative d dx of a over x is equal to a negative a over x squared. And that's pretty simple because it'd be like ax to the negative 1. And so that'd be like negative 1 ax to the negative 2, right? And so when you clean up, you get to here. So we see that the derivative of 2 over x is going to be negative 2 over x squared, right? And so we're looking for negative, well, first of all, a negative answer, so not any of these. Negative 2 over x squared, yeah. Okay, so no, I said in red, right? So let's stay consistent. Okay. So D. Yeah, okay, cool. Again, the rest of them are going to be available on Patreon, on my Patreon page. And I'll leave you a link to my Patreon page, and you could unlock them on my Patreon page. All right, I hope otherwise, you know, you found this helpful and you've had a great day. All right, love and peace for everyone, and Jesus in all of our lives, everywhere. Okay, take care.